This is Jacob's Algebra, Chapter 13, Lesson 6, Completing the Square. So in this lesson, we're going to cover another method of solving equations. Now, already we know how to solve equations like this one, x squared minus 6x minus 16 equals 0. We know that we can factor it and then set each of our factors equal to 0 using the zero product property. So if we needed to factor this, let's go ahead and draw our parentheses. We know that it would factor in equal 0. We know that we would have an x and an x. And to figure out what goes in these, we know because our final term is negative that we have to have a positive and a negative. What are our factors of 16? The factors of 16 are 1 and 16, 2 and 8, 4 and 4. We need a pair of factors that will subtract to 6. So that's going to be 2 and 8. Because 6 is negative, that means that our bigger one has to be negative. So our 8 is going to be negative and our 2 is going to be positive. So then we can say that x plus 2 equals 0 and x minus 8 equals 0 because the zero product property says that when you multiply two things together to get 0, then either one of those, at least one of the things you're multiplying has to be 0. So if I solve this left equation for x, I get x equals negative 2. If I solve this right equation for x, we get x equals 8. So x equals 2 and x equals 8 are the solutions for this equation. Now another way of solving this is to use completing the square. So when you're going to use completing the square, let me write out this same equation first. X squared minus 6x minus 16 equals 0. What you want to do is have only your x terms on the left side. So I'm going to add 16 to both sides, and we'll have x squared minus 6x equals 16. I added 16 to both sides, so that left me with a 0 here, and it added 16 to the 0 on the other side to get 16. Now what I want to do is find what square would have negative 6x as a middle term and x squared as a first term. Okay, so I know I'm going to make some kind of a square here. What I need to do for this is take this first term and take the square root. The square root of x squared is x. Then I need to take this second term. I'm going to divide it by 2. So negative 6 divided by 2 is, negative 6x divided by 2 is negative 3x. And then I'm going to divide it by this. So negative 3x divided by x is negative 3. And when I make this square, what it's going to multiply out to, we're going to square our first term, which is x squared. Then we're going to have the double of the product of the two terms. 2 times x times negative 3 is negative 6x. And then we're going to square our last term. Negative 3 squared is 9. Well, I added 9 over here on the left side. You can see that wasn't here before. So that means I have to be adding 9 on the other side. So I have 16 plus 9 on the right. That means that x minus 3 squared has to be 25 because 16 plus 9 is 25. Now I have a square on the left side that has my x inside of it, so I can take the square root of both sides. So I'm going to take the square root of both sides, and over here on the left I will have x minus 3. On the right side, the square root of 25 is 5, but we have to say plus or minus 5. And the reason why we have to say plus or minus is because all we know is that what was inside of the square root was squared. So we don't know if x minus 3 is a positive number or if it's a negative number. Because a negative number squared is going to be positive, and a positive number squared is going to be positive. So we don't know whether this was positive or negative. So on the right side of our equation, we're going to write plus or minus, and then whatever the square root of this is. And the square root of 25 is 5. Now we need to solve for x. To solve for x, we need to add 3 to both sides. So we'll end up with just an x on the left side and 3 plus or minus 5 on the right side. So now we need to figure out what is 3 plus 5? That's 8. What is 3 minus 5? That's negative 2. So our x is going to equal 8 and negative 2. And you can see that's exactly what we got before for this same equation using the factoring method. So completing the square is just another method. Sometimes completing the square is an easier method to use than factoring because sometimes factoring only works when you have something that's factorable. Completing the square can work even when what you have is not factorable. So let's move on and try a couple of the example problems. So let's start with number 4. Number 4 is just like number 11 that I assigned for homework. It says add a term to each of the following binomials to change it into a trinomial square. And then it says draw diagrams if you need them. Okay, so for part A, what they give us is x squared plus 8x. What they're wanting you to do is figure out what you would need to square to have x squared and 8x be your first two terms, and then you need to figure out what the last term is. So to write this as a square, the first thing we need to do is take the square root of our first term. The square root of x squared is x. Then we take our second term, we divide it by 2. 8x divided by 2 is 4x. Then we divide it by this. 4x divided by x is 4, and it's a positive 4, so we write it in here. Now, if we multiply this out, the square of our first term is x squared. The double of x times 4, 2 times 4 times x, is 8x. And then we'll have our last term is going to be the square of the 4, and that's 16. So when it says add a term to each of the following binomials to change it into a trinomial square, for the problem that starts off with x squared plus 8x, the term we need to add is 16. Okay, let's look at another one. Part C, we're given 4x squared minus 12x. And we need to figure out what the last term is on this if it's the trinomial form of a binomial square. So we're going to write the square below it. What we need to do is take the square root of our first term. What is the square root of 4x squared? Well, that's going to be 2x. Then we take our second term. We have negative 12x. We divide it by 2. Negative 12x divided by 2 is negative 6x. And then we divide it by this term. Negative 6x divided by 2x is going to be negative 3. So now we need to check it and make sure that what we have is right. We're going to square our first term. 2x squared is 4x squared. Okay, that works. 2 times 2x times negative 3 is going to give us negative 12x. So now we just need to square our final term. Negative 3, when you square it, is a positive 9. So that's the term that we need to add to make this the trinomial form of the square of a binomial. Okay, let's get a new page now and look at number 4, part D. Part D, we have 25x squared plus 70x. And we need to figure out what needs to be added to this. Okay, so we need to write our binomial square. We take the square root of the first term. What's the square root of 25x squared? Well, the square root of 25 is 5, and the square root of x squared is x. Then we take our second term and divide it by 2. 70x divided by 2 is 35x. And then we divide it by this term. 35x divided by 5x is a 7. It's a positive 7. So now we check to make sure that what we have is right. When you square 5x, you get 25x squared. And then we need the double of 5x times 7. 5x times 7 is 35x, and the double of that is 70x. So we're good. That's what we're supposed to have. Then our last term is going to be the square of the 7. So the square of 7 is 49. So that's going to be the answer for part D. Now we're going to do one more from number 4, which is part F, and that's a squared x squared minus 4ax. And then we know there's going to be something else over here. So let's write this as a square. We need to take the square root of this first term. The square root of a squared x squared is ax. Now we're going to take our second term and divide it by 2. Negative 4ax divided by 2 is negative 2ax. And then we need to divide it by this first term in the parentheses. Negative 2ax divided by ax is negative 2. And now we need to check it. When we square ax, we get a squared x squared. When we take the double of ax times negative 2, that's 2ax times a negative 2 is negative 4ax. Now we need to square our last term. Negative 2 squared is a positive 4. So that's going to complete our trinomial. So that was number 4, which is just like number 11 that I assigned for homework. Let's take a look now at number 5. Okay, so for number 5, what they do is they have worked through a problem for you, and you're supposed to say, what they did on each part to get from the previous step to the current step. So we're starting off with 9x squared plus 12x minus 7 equals 0. And part A is 9x squared plus 12x equals 7. So what did they do to get from 9x squared plus 12x minus 7 equals 0 to 9x squared plus 12x equals 7? Well, you can see that they added 7 to both sides. So I'm going to say plus 7 on both sides. So they added 7 to both sides to get from this first step to get to step A. Okay, for part B, we see 9x squared plus 12x plus 4 equals 7 plus 4. Okay, well, obviously they added 4 to both sides here because we did have just a 12x here, and now we have a 12x plus 4. And we did have just a 7, and now we have a 7 plus 4. So that's a plus 4 on both sides. Then still as part B, right underneath this, we have 3x plus 2 squared equals 11. Well, you can see that this is the binomial form of the trinomial. So if we take the square root of 9x squared, we get 3x. When we take the square root of 4, we have 2. And the 12x is 2 times 3x times 2. That's going to give you 12x. So this is the binomial square form of the trinomial. And then 7 plus 4 is 11. So you don't have to say what they did here. This is just kind of a freebie step they threw in. And then part C is 3x plus 2 equals plus or minus the square root of 11. What did they have to do to get from this step to part C? Well, it looks like they took the square root of both sides. So I'm going to say square root both sides. Oops, I left out my E. Okay. Now look at part D. Part D says 3x equals negative 2 plus or minus the square root of 11. So what did we do to get from step C to step D? Well, we had a 2 here and we don't here. So we must have subtracted 2 from both sides. So I'm going to say minus 2 on both sides. Okay, part E says x equals negative 2 plus or minus the square root of 11 over 3. So what did we do to get from step D to step E? Well, we were multiplying x by 3 in step D, and in part E, we just have x. So to undo the multiplying by 3, we must have divided by 3. So I'm going to write divide by 3 on both sides. So that's what it's asking you to do. This is just like problem number 12. In problem number 12, they do the exact same thing. They show you a problem and they work it out step by step. And what they want you to do is write out what they did to go from each step to the next step. Okay, so now let's look at problem number 6. Problem number 6 is just like number 13 that I assigned for homework. It says this exercise is about the equation x squared plus 6x equals 40. For part A, it says solve the equation by writing it in standard form and using the factoring method. So they want you to use the method that we learned in lesson 4. So writing it in standard form means that we have our polynomial on the left and the right side is equal to 0. So to make the right side equal to 0, we're going to have to subtract 40 from both sides. So we'll have x squared plus 6x minus 40 equals 0. Now that we have it in standard form, we can factor the left side. So how does this factor? Well, we know we're going to have an x and an x. Now we have to look at what are the factors of 40. The factors of 40, we have 1 and 40, we have 2 and 20, 4 and 10, or 5 and 8. Those are all the different factor pairs to make 40. Since we have a negative in front of the 40, that means we need to subtract. So we need to find the pair of factors that will subtract to make 6. That's going to be 4 and 10. Since the 6 is positive, it means our bigger factor needs to be 10. So we're going to have minus 4 and plus 10, that equals 0. We'll set each factor equal to 0. X minus 4 equals 0. X plus 10 equals 0. And then we solve to get x equals 4 and x equals negative 10. We'll do part B on the part 2 video. So this is how you solve this problem using the factoring method we learned in lesson 4.